In this video, we'll be exploring relational databases. First, let's look at what a database is. A database is a place where you can store data, and more importantly, from where you can retrieve it again afterward. Databases are used in many places. A common use case is for businesses to store information about their business operations. A company could use a database to store information, for example, about its customers and its sales and stock. A streaming service could use a database to store information about its users, videos, and the number of views. A hospital could use a database to store information about their patients, test results, and so on. You can store almost any kind of data in a database. The applications are practically endless. There are several kinds of database, but the most widely used are what we call relational databases. They are called that because they can be used to define relationships between the sets of data they store. Relational databases store data in sets called tables. A table is basically a list of records that all have the same attributes, which we also call columns or fields. Each entry in the table is a row or a record. The table is used to store data about a thing or an entity. For example, suppose a company wants to keep track of all its customers. In a database, it would define a table to hold all its customer records. A customer can be considered an entity, and it has several attributes that a company might want to keep track of, such as the customer's name and telephone number and address or birth date. A table of customers would then hold a data record or an entry for every customer that the company does business with. An order might be another entity that the company would like to keep track of. For this, it creates a table in which to store all the orders that are placed by customers. Whenever a customer places an order, an extra entry would be added to the orders table. The orders table would contain information like the date the order was placed and the value of the order. It would also contain the customer number, so that we know which customer placed the order. To find and identify a record in a table, it should have what is called a primary key. A primary key is one or more columns whose values help us uniquely identify and find each record in the table. Let's think about what a good key for a customer table would be. We could make the name of the customer the key, but this would be a problem if, for example, you have two John Smiths. The problem is that it's not unique. If all we had was the customer's name, it could refer to more than one customer, and that would be a problem. You could maybe use the telephone number of the customer because that should be unique. If the customer changes their number, however, it might be difficult to find their record again. Or if someone else takes over that phone number, we would have the wrong customer's details stored under that key. A telephone number would also make a poor choice for a primary key. A common practice is to use a unique number. Every time we create a new customer on the database, we give them a number that only they have and use that as their account number. The first customer might have the number 1. Then we increase the number each time we create a record for a new customer in the table. There might be 2 John Smiths, but they would each have their own customer number. So the most practical primary key we can devise that will uniquely identify a customer number is a number we assign ourselves. We can do the same thing with the orders table, where each time we create a new order for a customer, we would assign the next number to it. This way, when the customer contacts the company about their order, they can easily look up the order using the number given. When designing a database table, careful thought must be given to what attribute to use as a primary key. In many cases, creating an attribute with a self-defined value like customer number or order number is the way to go. When we create a primary key on a table, The database will ensure that the value in that column can occur only once, and if we try to add a record with the same primary key value, the database will prevent us from doing so. Like we said before, the primary key of a table can consist of more than one attribute. Suppose we want the customer to be able to order multiple products at a time. One option might be to create a few attributes on the orders table to cater for several products. This would not be very practical though, because we don't know whether a customer might order 1 or 20 products in one go. A better solution would be to create a new table to contain the items of an order. The order item would be a new entity. The order items table would share a key with the orders table, which is the order number. But it would have another key field to identify the item belonging to each order in the table, which would make each entry unique. The result is a composite primary key, a key made up of more than one column of the table. The new table allows us to capture any number of items per order and allows us to capture other information for each item, such as the quantity and value, which would have been impractical to do on the orders table. Also note that there is a relationship between the orders table and the items table, something which we'll look at in more detail. We've seen one example of relationships between tables with the orders and order items tables. To create relationships between tables, we add the primary key attribute of one table as an attribute on another table. In the order table, it makes sense to put the number of the customer as one of the attributes. This creates a relationship between the customer and the order's entities, called a foreign key relationship. It is called that because the attribute in one table is a key in another table. This relationship lets us look up the customer details from the order without having to include all the details of the customer on the order itself. This relationship is also useful the other way around, because it could help us if we wanted to pull up all the orders that a customer has placed by looking up the customer number in every order record. Let's talk about something called normalization. Suppose we had a table containing a list of companies. We have a unique code for each company, which is our primary key, and the company name. We also store the city where each company operates. We might also be interested in the population in each of those cities as we make sales decisions based on that information. You might see that there are some problems with this design. Firstly, the information about the population is duplicated in several places. Even worse, if the population of any of those cities changes in the future, we would have to remember to find all the records referring to that city and update it. This not only creates more work for us, but it could easily lead to inconsistent data if we forget to update the population in one place or maintain it incorrectly. The truth is, the population information is really part of the city and not part of the company in each record. To solve the problem, we would create a separate table that holds information on cities. This way, there is no duplication of information, and if anything changes relating to a city, we would only have to update the information in one place. The process of designing a relational database to ensure that the data remains consistent, avoids duplication, and is easy to update is called normalization. One of the guiding principles of normalization is to ensure that any information belonging to an entity is stored only once in the table representing that entity and not in other tables. Here, for example, it would most likely not make sense to add the customer's last name on the order, as it is an attribute of the customer. The last topic we want to look at is indexing. Let's say we wanted to look up all the orders for a customer. Without an index, the database would have to look through every single order record to find all the orders for that customer. If there are millions of records in the orders table, this could take a very long time. To speed up the process of finding data in a table, we can define what is called an index on a table column. Just like the index at the back of a book can tell you all the pages on which a certain word occurs, the index on a table allows you to look up all the records that have a specific value in a column. In our example, the database would keep track of all the order keys for each customer number as the records are updated. Then, when we try and find all the orders for a customer, the database can simply query the index to find all the order records for that customer. This can make querying the table hundreds or even thousands of times faster. Indexes also have another purpose. We could define what is called a unique index on a column, like the phone number on the customer table. A unique index ensures that the value in a column may occur only once. This could be useful, for instance, to ensure that we don't add different customers with the same phone numbers more than once. Here, the database would also prevent us from creating such a record. It would further double up as a way to identify a customer by their phone number, with the advantage that it can be changed later, unlike the primary key. Note that the primary key on a table is in fact also a unique index, with the difference that its values cannot subsequently be changed. Well, hopefully this short introduction gave you some useful information on relational databases to start with. If you have any questions, I would love to hear from you in the comments. Thanks for watching.